Hey everybody, Jay Weidner here. This is our new studio. And I think this is not the first time we've shot here, but it's one of the first times. There we go, that's much better. We're here with our local alchemist, Ken Swartz. Hey Ken.
Hello.
And thank you for watching. So Ken, I want to know about, I want you to prove to us that alchemy is real
Okay.
in this show. All right. You are working on something called Moxy Fusion. We've talked about it before, but I really want to understand how Moxy Fusion works, because I believe that this is probably the secret to the alchemical transmutation.
Yeah. Well, the first thing is Moxy Fusion. It's an abbreviation for metal oxygen fusion,
Right.
And it's literally 1 billion times easier to do than traditional hydrogen isotope like tritium, deuterium, or deuterium fusion. And so, but it's not really well. It's been around for a long time. People didn't understand it. There's countries around the world doing research in it right now, and lots of private corporations and individuals don't know that number because they don't talk about it. But it's just kind of something that came to understanding. And now the history of it, it first started really well in the current form that I would call Moxy. It started with these two guys, Osawa and Kushi. There were a couple of Japanese researchers in the late 1950s. They discovered it. And in the early 60s, they gave their their confirming experiment. What they did is they basically used a power supply for a sodium street lamp. And instead of and then they made this special sodium street lamp bulb to fit into it. And it was very ceramic because it's going to get hot and a lot of pressure in there. Had a little quartz window. And so what they did is they put some sodium in there and an equal amount of oxygen. And then they pressurized it with argon gas, which is a noble gas.
Yeah.
It doesn't do any chemical reactions, but it's very electrically conductive. And they turned it on, and of course, through the little quartz window, you could see the orange-red glow or the yellow-orange glow of a sodium street lamp. We've all seen them, right? We know what it looks like. But over several hours, it turned to a purple. And purple is the sign of potassium. And so if you were to take oxygen and fuse it with sodium, you would get potassium. And so they turned it in from a sodium street lamp into a potassium street lamp. And this was like a defining experiment they came up with, proving their whole concept. Now,
What is their concept?
Their concept was like a yin-yang thing, where one side of the atomic elements was yin and the other side was yang. And so obviously sodium, let's say, is on the yin side, and oxygen would be on the yang side, the other side of and by putting the yin to yang together, they could make new daughter elements.
Ah.
Now in the West, we call that electronegativity. But they used oxygen. They didn't use let's say fluoride, which is even more electronegative than oxygen. And there's reasons for that. It's just the way it sets up.
Okay, so then what's the ultimate goal though of the experiment?
Well, to make new matter. And that's Osawa and Kushi did the experiments easily reproducible, where they could turn sodium and oxygen into potassium
So they transmuted it.
They transmuted matter, and that's not. And then there's more that came to this. One is a guy named Ken Soldiers.
Yeah.
And he was one of the Lenners or cold fusion researchers, and he was making what's called a soliton, which is the key behind Moxy. And what it is it's basically a smoke ring of electrons.
Yeah.
And he would fire, and normally electrons repel each other, but because they're following each other in a smoke ring, it's actually a current, and so it stays together as a toroid, a spinning toroid.
Right.
And he would be firing these through a vacuum at a metal surface. It was usually aluminum, and then he would examine the metal surface and punch little holes in the metal surface, and he would examine it with X-ray spectroscopy. And it was always just aluminum, until one day, for some reason, he put in a plate. It's probably accidental, and it was heavily oxidized. So now there's a big layer of aluminum oxide on top of that aluminum plate. And he fired it in and punched the holes. But when he looked at it spectroscopy wise, it was actually, he saw the appearance of new elements, fusion. that aluminum and oxygen had fused together and created these new elements that would kind of exist if aluminum and oxygen did fuse together.
So he fired a toroid of electrons and it hit the metal plate that had been oxidized. And then this created more transmutation.
Yes, exactly, because the oxygen and the aluminum had fused together. And that's where the whole concept of metal oxygen fusion, Moxy, came in.
Right.
And there's something about these solitons like that has power. In fact, we brought a demo today for you guys lucky to be here. And this is, well, you got to spray the smoke. And this is, you can buy this off Amazon. This is a smoke ring creator. So just give it a whole bunch. You might be seeing those. We can fire this smoke ring all the way across the room.
It will move.
Yeah, see, look at that. It's
moving stuff
yeah,
across the room.
yeah, 20 feet away.
20 feet away.
Yeah, and so it's actually a great gag toy that you can buy on Amazon or elsewhere.
Yeah.
So I don't know what they got. Does it have a name? Anyway. Oh, yeah, here it is. It even has but that's the soliton, and it's a smoke ring of electrons. And now normally, even in the core of any star in our galaxy, anywhere in the universe, there's always just one electron for one proton. Sometimes they get squeezed together into a neutron, but it's always this 1-to-1 ratio. An electron weighs, a proton weighs 1,820 something times the weight of an electron. And yet they have exactly the same charge.
Right.
Now within the soliton, which is a smoke ring of electrons, your weight ratio of electrons to baryonic cores, nuclei, the cores of nucleus that is being fused by Moxy might be 1-to-1. So you have many times, that's a huge ratio. So inside that soliton, you've got the electrons spiraling on the outside one way, and then on the inside you have baryons spiraling on the other way,
right.
And it crushes them. It brings them together. It's a bit like for scientists out there like muon fusion, but it's even more than muon fusion. It's better than tau fusion, and so you can make it super degenerate matter, and that allows Moxy fusion. Usually that you get that toroid, the spinning smoke ring, the soliton electrons and baryons, and they impact on the anode surface or impact on a metal oxide surface and brings in the metal oxide, and then they squeeze it together such that that it allows fusion to happen because it's super degenerative matter. It is more degenerate than in the core of any sun in our galaxy, in our universe, could possibly ever be. But we do it in the lab on the tabletop.
And the oxygen is a must, but why?
Well, oxygen is contrary to belief, they have this whole belief that first it started with Rutherford. First they used to think that matter was like a raisin bread, and the electrons and protons and neutrons were scattered about like the little, the raisins and whatever else is in there, right?
Okay.
And then Rutherford discovered, no, there's a tiny nucleus, and the electrons, quote, orbit far away, and it's 99.999% space.
Yeah.
But still, if they believe at the center of that nucleus, it's like a bunch of M&Ms that are just kind of put together. You can see it on any diagram,
Right.
but that's not the way. There's actually a physical structure around a rotational axis, and it's open cubic packing for the main building blocks, which are the alpha particles. That's 2 protons, 2 neutrons. It's the core of a helium atom. And that's why you get the odd even rule in matter creation. For matter that is evenly, which means you're using a full block of alpha particle block, are 10 times as abundant as those that use half a block. It's the odd even rule. And they have this thing where they say that the nucleus is made of these various layers or orbitals, just like the electrons are.
Fails.
Yeah, whatever. But that's not true. It actually has a physical structure. That's why electron relaxation can happen and all this other stuff. But I'm not going to go there because I have gone there. You can figure it out. It's easy to figure out. You can do it. But that's the core of it, the matter, because it works. There are countries all around the world doing the research, turning it out. People are actually turning. If you go to page 30 in my paper, you can download the paper, by the way.
I'll link to it.
Yeah, it's called, just go Moxy Fusion, MOXY, Fusion ResearchGate, and you can download it. There's been thousands of downloads all around the world. And so this is a technology that's being done right today. Right today, people are taking tungsten oxide in an argon atmosphere and making gold right now. And the platinum group metals using zirconium hafnium oxide.
So there's like recipes.
Yeah, exactly. It's already happening. It's in the paper. Some of them aren't in the paper. But if you go, I mean, I've been on Jean Claude. I've been on you before. I've been on all of these. Yeah, Jeff Rentz on the David Morgan show. I've just been on all of these different shows and talked about it. So, I mean, if you really want to go into particulars, just go to one of those shows and you can listen to me talk about it. And it's easy technology. That's what Osawa and Kushi did. They literally used the power supply of a sodium street lamp, right? Since they've been going over to the digitals, the LEDs, there's just whole warehouses full of that. That's your power supply. I've talked about it, and then you just build your own little crucible, and away you go, making whatever
So somebody could get your paper and build this thing.
Oh yeah, you get the paper, and then you also get the paper. You read the references. The paper has references because each thing that I show 7 different ways that people have done Moxy Fusion. And the one was these 2 guys, Yori and Krilio, and they did it back in 2004. What they did is they took 2 tungsten rods in like a water potassium solution, but you have to have an electrolyte. That was potassium, and they just pounded the hell out of them, just massively did it. Then they did spectroscopy afterwards, and there was the presence of gold, the presence of rhenium. What's even more interesting is the presence of beryllium and thulium, which thulium has a lower atomic weight than tungsten. So not only did they actually get, they not only, in some cases, because tungsten has 4 main stable isotopes. And so when the oxygen fuses with certain isotopes, they'll build up to, let's say, gold and rhenium. And other isotopes are unstable for various reasons, and some of those will break down, and they'll release what I guess would be a double alpha, or a double alpha plus a neutron, which is a beryllium, right? They have the beryllium breakdown, and then you get the thulium on the other side. And that shows fusion, because beryllium is only made in fission reactions. So you have a fission thing, and in the paper, at the very end of the paper, I don't know, page whatever it is, right before the thing, there's a Dr. Bass, and Dr. Bass was taking thorium, and with 300 watts of electricity, converting 1/10 of a gram into 2 copper isotopes, a copper isotope and a tin isotope, which were different from what you find in the earth. Unfortunately, he didn't do his math right, because it also made a radioactive xenon, which he was inhaling, which is why he's the late Dr. Bass. But that also happened to Fleischmann, which we could, and
So
others.
there's danger then.
Oh, there's huge danger in doing this if you don't know what you're doing. Like in the Fleischmann and other people that are doing the cold fusion research, what they do is they're getting like alpha particles, or they're getting helium nuclei, which are from the alpha particles. And some guy decided for some reason, you know, the radon detectors you use for your basement or your house, right? Inside of it's this P39. It's like a resin, plastic resin. And what happens is if a radon atom goes under radioactive decay, it shoots out an alpha particle, it has to be aimed at that chip. It'll punch into it and makes a weakness. Then you can take the chip and you can put it in hot sodium hydroxide, and it leaves a little pit. And this is in the paper too. And then you can count the number of alpha particles. And so this guy, just for some reason, decided to hang a bunch of those little chips, resins, things, P39s, right over on the top of one of those cold fusion cells using platinum or palladium electrodes, and they were just totally saturated. It'd be like hundreds of times your worst radon basement, because what was actually happening, there was fusion going on, but in the case when you have platinum would fuse with oxygen to make radon, which is a radioactive gas that emits alpha particles, and you breathe those in, and because it's a noble gas, it doesn't interact with anything, so it could be anywhere in your body when it goes off. And an alpha particle, if you can imagine a gamma ray as like a pellet from a pellet gun, an alpha particle is like a shotgun slug in the amount of damage it's going to do. And so you just, you know, and so that's why. And so,
all right, so if corporations found out that using a little tiny bit of electricity could get them gold.
Yeah, gold and the platinum group metals. And
then why aren't corporations flocking to all of this?
Well, some are in countries, but you know, most scientists can't get around the idea that there could be any type of fusion other than oxygen, or other than helium nuclei.
Yeah, right.
You can put like 2 deuteriums together, or some tritiums and deuteriums or something.
So they reject the idea.
They reject the idea outright that it's impossible.
I got it.
It's not in their box. And so, and we have a bunch of actual working Moxy Fusion reactors we share with partners and stuff.
Yeah.
So that proof of concept. But see, the thing is, everybody's looking for third party. Well, we've had our paper up on ResearchGate since 2014 in one state or another. There's been a couple edits, but
10 years.
yeah. But anyway, they had there was a group called the Scotia Group out of Scotland, as you can imagine, Scotia, and they work with the University of Vienna.
Yeah.
Or no, the University of Valencia. They worked with the University of Valencia, and they reproduced our experimentation. And I mean, what we did is we used the Osawa-Kushi protocol, and instead of using sodium and oxygen, we used deuterium and oxygen, which would give you the highest. If you wanted to make electrical energy and get the most heat out of it, oxygen with deuterium would be the way to go for power production. So we use that, and it's a lot less caustic and damaging than sodium hydroxide. And so we use that for that proof of concept. And of course, we were actually doing our third-party verification after we proved our stuff. We did a TSA Systems out of I-25. TSA Systems makes all the stuff that TSA uses to scan for radio. But they had a great super detector, 50 band wise. It's got, it's really good. So we went there for third-party verification, which anyway, but the Scotia group probably didn't have access to that, so they did it differently. What they did is they got a glass B detector. A glass B detector can detect the appearance of almost a few atoms of a new substance, an ionizable substance like fluoride. So when we took ours, we take oxygen and deuterium in argon, pressurized argon environment, would fuse into fluoride 18, which is unstable and soon breaks down through electrocapture, pulls an electron out of the shell orbitals and pulls it in and turns itself into oxygen 18. And that releases a bit of energy, and that's your power that runs things. Well, and we could see that on because we had 50 channels.
I want to get this right. You're saying that you can create free energy too?
No, it's not free because you got to put it together. You got to build it.
Okay, not free.
Yeah, but you can extract
cheap
energy. Oh yeah, and not on that side, like Dr. Bass. Right now when you use our fission plants, and they have to take like what uranium-235 is 0.6% of uranium, and they have to separate it. Well, with Moxy Fusion fission, which was Dr. Bass was doing, even though he didn't understand it, you can take any uranium, any thorium, any actinide, even cesium, and you can fission fuse it. So you fuse it together to make this new unstable mol atom, and then it breaks apart into non-radioactive metals that are useful and a short-lived radioactive gas, which soon decays into a non-radioactive isotope. And so you can extract 100% of the energy out of uranium, 100% of the uranium out of thorium, 100% of the uranium out of cesium, and you're getting some energy even out of the tungsten. Yorio and Creo are getting energy out of the tungsten reaction. Okay,
so you fire the electrons at the metal.
No, the soliton, the electron spoke
electric circle. Spiral, and literally the metals are transmuted.
Well, the metal oxides, they have to be a metal oxide,
right?
And as the thing, it's really hot. It's really got Turing goes.
Sure.
You have to have the pressurized argon because that's kind of like it's kind of a moderator that drives the process by 1,000 times, and it just goes in there and it hits the metal oxide layer and it totally vaporizes, or does more than vaporize it. Atomizes and it pulls it inside that smoke ring of electrons along with the argon gas, and then kind of crunches it together and creates new elements through Moxy Fusion. That's the key of it all. And this has been proven 7 different times, actually 8 times if you throw in the Scotia group, and you can actually find their paper on ResearchGate too. They generously published it there as well.
So in Alchemy, they claim they're doing this, and they're keeping it all secret, not telling anybody what they're doing. And then there's also in Alchemy warnings about doing it, that you can die.
Yeah, but you can also do it with this similar thing with sound, and that's the Leclerc effect. You go and look up the Leclerc effect. Leclerc was this researcher with his buddy, and they were doing it. And what they were doing, they were making these little tiny bubbles, little sonic bubbles, tiny ones. And he was actually doing it for the Naval Research Institute, because what he was doing is using those little bubbles to etch little holes in computer chips, where they could do three-dimensional layering of computer chips that makes them more efficient. So he could punch these little tiny holes. Well, he was seeing what he thought was maybe transmutational effects. But so what he and this buddy, they obviously proved it side. So they decided they were going to do a big experiment. So they got a bunch of really thin aluminum foil, and they put it, of course, exactly the same as a roll, right? Exactly the same. They put in water. Fortunately, they didn't put in deuterium water, because then they did the micro bubbles, which could cause trillions of these bubbles, right? And they both got severe radiation poisoning. I don't even know if they're alive today. But the government learned about it because these guys were stepping outside their bonds, and they were trying to get treatment for severe radiation poisoning. Because that's one of the things about Moxy Fusion, by the way, that I didn't bring up, like for Fleischmann and Pons and all these other guys, Ken Shoulders, is they're walking around because and we've actually gave machines to people and to these old nuke guys, and they would not take our advice to actually have the X-ray protection, because it's coming out in the X-ray band. Because Moxy Fusion lowers the Coulomb barrier, the energy it takes to put atoms together by a millionfold, billionfold. So the energy that comes out is in the X-ray band, not in the gamma ray band. And so these guys are walking around with Geiger counters looking for gamma rays all the time. They're being cooked with X-rays. And that's what happened to Leclerc. And they got really sick. And later they actually went and looked at their stuff, and they found this strange green material, like it accumulated in a kind of a mass at the bottom of their experiment. And they had it spectrally analyzed, and was like all of the sorts of materials you might expect if aluminum and oxygen fused, and then the byproducts of those fused. And so they said it resembled the ashes of a supernova. And I don't think either of them are alive today, but and that's another way. But that's Moxy Fusion, because when those nanobubbles collapse, they collapse into this tiny thing, and you've got water moving at extreme velocities. In fact, you can somnoluminescences where the bubbles collapse right into themselves, and you can actually see glowing light, right? That's how hot it gets, hot enough to make white light, like the energy of the sun's surface, which is, and so that's another physical way, and alchemy could do that. If imagine if you made the right sound frequencies, the high frequency pitches that these guys did, you could technically in the past. I mean, I just
so they were getting transmutation from this?
Yeah, absolutely. Just like it's Moxy Fusion, because you have oxygen, you have a metal, and you have the impact, that little toroid impact that's spiking in. It has the electrical and physical energies the same as, it's essentially a toroid, just like this. I mean, it's the same, they're making solitons inside these collapsing nanobubbles. And the solitons are full of oxygen, are impacting the metal, which creates metal oxides. And if they had an argon atmosphere, it would drive the.
So does the toroidal shape is having an effect on the experiment?
Well, I think the toroidal shape is part of the process by which, normally electrons repel each other, and protons would too. But if they're spiraling around following each other, it's like an electric current. And so they stay together into that smoke ring type formation. I mean, you can buy these on you can just do it. I know it's kind of hokey, but there it is. See the smoke ring pass by. And again, yeah, and on the other side of the room, 20 feet away, it can make the cloth move pretty dramatically.
Right. Interesting. So there's probably a large chance that the alchemists had discovered this somehow.
Yes, exactly. It could easily, it's easily possible that this could be discovered through some process. And I mean, I don't know, and who did the alchemists learn it from, right? That's
They say the Egyptians.
Yeah, and the Egyptians say they got their stuff from people, from visitors from Sirius.
Yeah.
And so who am I to, that's what they say. And the Dogon tribe, and I think in one of the first dynasties, a bunch of Egyptian priests got run out, and some of them migrated to where the Dogon's tribes were, probably, and passed their knowledge on. And thousands of years later, it's preserved. And
probably pre-dynastic.
Yeah.
Egyptians.
Yeah.
They were more advanced than the dynasty.
Yeah. So, but sometime they carried that knowledge, and because that's where the knowledge came from, the Egyptians.
Yeah, Robert Temple has been on the show, a good friend of mine, and he wrote the book about that, the Sirius Mystery.
Yes.
All about the Dogon and knowing about binary star and Sirius.
Yeah, which is impossible for them to know about it.
It's impossible. It's impossible for the Egyptians to know that.
Yes, exactly.
Yeah, and yeah, so this whole thing kind of plays together in this kind of big dance where we're finally finding out that alchemy is real.
Yeah, but the thing is, like the Osawa Kushi thing, okay, they get this, they're claiming they can almost make potassium at commercial levels. And that's like, sorry, guys, you know, if you can buy tungsten oxide for very cheap, and you know, and the argon's pretty damn cheap, and the machines, they're not that expensive. So, you know, commercialized, you could probably make gold and other platinum group metals. The platinum group metals, you use zirconium, hafnium oxide. You can buy it a powder from China for 50 cents a pound, right? The argon costs maybe, you know, 25 cents. The machine costs, well, it's a little expensive, but you can make cheap versions. And you know, you're gonna be able to make platinum and gold for under $100 an ounce. But what's really good out there, just letting people know, silver is by far the hardest of all the metals to make. Because we found, like, if you did the platinum group metals.
By the way, they say that in alchemy too, by the way.
Yeah, so it's the hardest to make. So at some point,
silver is harder to make than gold.
yeah, so if metal prices someday will be fixed by the cost of their production, silver at some place is going to be 2 or 3 times more expensive, maybe even more expensive than gold by weight.
Because they're going to be
Because it's harder to manufacture, more electricity, different conditions. You got to, it's harder to do it.
And if you're going to make gold, if you're going to do this experiment, you want to do it now, because if it's true, and I think it is, then the price of gold is going to really start dropping.
Well, once the reality sets in. Now, there are people out there that are already doing this. Some of them I've helped, but you don't need my help. You just have to read the damn papers.
How long would it take you to make an ounce of gold?
I don't know. With our machines, we have our demo machines just run on the hydrogen, oxygen stuff. And we just have little fusion candles. That's all ours are.
Right.
Little fusion candles. But if we did ours, it would probably take a while. But I mean, if you were doing like Yaye and Carrillo in a pressurized argon atmosphere, and you're just using tungsten oxide right off the bat, pressurized, and it doesn't necessarily have to be argon. Argon's cheap and easy. Probably krypton and xenon and neon would in certain cases be even more efficient. But if you ever look at the price of neon lately, holy, because they use it for etching computer chips. And the main supply for neon used to be mines in Ukraine, Eastern Ukraine, which now are not producing. So the price of neon has gone to the roof.
Yeah. Well, that's really interesting. Really, really interesting.
Yeah. So it's doable, and you can do it now. And I mean, this is like Osawa and Kushi, they got suppressed. They got totally crushed, and they were didn't get any funding, and they continued to do their research. And in other places, people died. Of course, some people were thinking all the cold fusion dudes were dying because the government was killing them.
Yeah.
But actually, they were, you know, breathing.
Not taking
Yes.
precautions.
Yeah, they Madame Curried themselves, so to speak.
Yeah. And so we could create an army of people doing this.
Yeah, it's already happening. It's our governments are doing
That's
it,
what you guys
corporations are
wanna
doing
do.
it, individuals are doing it, it's already happening. I didn't come up with Moxy Fusion, right? This has been going on since before I was born, was suppressed. All I did is Gary Rodriguez and I and Ty Simpson, you know him, we actually did it, the original experiments, and we confirmed Osawa and Kushi's discovery. And then the Scotia group and the University of Valencia confirmed our discovery, which is the reconfirmation or double confirmation of Osawa and Kushi. So this is stuff, and there's even some guys, some Japanese researchers back in 1903, his name escapes me at the moment, who was also showing some evidence. So this is along, you know, this is happening in Japan back in, but you know, if Osawa and Kushi had not been suppressed in the early 1960s, when they showed like just primo evidence, right? We could have had working fusion reactors by the early 1970s. There never would have been any Fukushimas. There had been no carbon crisis. There'd been no energy crisis. That would have all never have happened.
So Moxy Fusion gives us cheap electricity and transmutation of elements.
Yeah, it allows you to make all the precious metals and the rare earth metals for a fraction of the cost it does for mining them now.
And anyone can do it.
Anybody can do it. It's online. Thousands have downloaded it. Countries are doing it. Corporations are doing it. Gobs of individuals are doing it. I know some of them. I've helped some of them, but you don't need me. You don't need, just read the damn papers and do it yourself. You know, it's not very hard, guys.
Yeah,
Hey, girls.
This goes back to my theory that the people who have developed this exotic technology, and I know who they are, you guys know that I know who they are, it's the US Navy, has decided that politics is not going to work.
Yeah.
And they're secretly releasing all of these technologies right now to undermine the entire political system.
Yes, but then again, my dad retired colonel from the US Air Force, so I guess I'm kind of stuck in between.
My dad was in the Navy.
Yeah, so born Navy side, so I guess I am more on the Navy side than my dad's side.
Yeah, well, the Air Force, they work closely with the CIA.
Yeah, they were formed in the same year, 1947.
Yeah.
They were given birth by the same mother.
Yes, they were, and the UN too.
The UN, yeah, all that stuff.
All that was, but somebody should do a whole book on the history of 1947.
Yeah,
Quite an amazing year.
yes, it was. It was a very transformative year. And of course, what also happened that year?
Roswell.
Roswell.
That's right.
Yeah, Roswell happened. So, I mean, is it a coincidence? I don't
I
know.
don't think so.
Are we coincidence theorists?
I know.
I'm not a coincidence
I'm
theorist.
not a
It's
coincidence.
just a coincidence.
I don't
It's just a
know.
coincidence something happened after that.
Yeah.
It's just a coincidence.
Just a coincidence, the death rate started rising right after.
Yeah,
started.
it's all just a coincidence.
Mhm.
But there's lots, actually, there are probably way more coincidence theorists out there than there are conspiracy
There
theorists.
are. There are.
And in fact, being a coincidence theorist is a very popular thing to be.
Yeah, most scientists are coincidences.
Oh, absolutely. And they showed it from their
Yeah.
behavior.
Yeah.
So,
And you can't really convince a coincidence theorist of what's going on. They can't see it.
no
It's
amount of
impossible.
evidence is going to change it because it's an emotionally held belief.
Yeah,
It's not an intellectually held belief.
that's right.
And
And so there are coincidences. There's no
yes,
doubt
there are
about it.
coincidences. But then, like synchronicity, if you talk about Carl Jung
Yeah,
and Freud, well, Carl Jung and Freud, they're having an argument about the nature of synchronicity and coincidence.
so Freud didn't believe it.
And they were talking, I think you got into Egyptian stuff, and all of a sudden a scarab beetle appears on the window
Yeah,
outside their office in Switzerland in like the fall where there should be no, impossible. And there's a scarab beetle on the window. So, which is kind of, what was that?
I don't know. You ever read Memories, Dreams and Reflections? His
Uh,
autobiography?
no, I have not read that book.
Not
It's
really.
something, and they translated it into English. So that finally, after decades.
Yeah, so he's sick at one point. He's in the hospital. He's got something wrong with him. I can't
Yeah.
remember what it is. And he dies. Carl Jung dies.
Yeah.
And he says he rose out of his body and he looked back down at his dying body on the bed. And he turned around and he started rising up above and he saw the curve of the earth. And he was going out into space and other bodies were passing by and some were coming in. And he said, he looked and one of the bodies passing by was a physician in the hospital that he was at.
Oh,
And then he rose way high, and all of a sudden, like a force of gravity started pulling him back down. And like in lightning flash, he was right back down in his body and he woke up and we found out that doctor had died at that moment.
well,
Yeah, great story.
yeah, I mean, it's hard. See, that's where the coincidence theory breaks down.
Well, and Carl Jung, he would record his dreams every
Yes.
night. And he kept having these dreams and he didn't understand them. And he was baffled. It went on for like a year. And then one day he was in somebody's library, their personal library, and they had a ton of alchemy books. And he started looking through them. And alchemy books have a lot of illustrations. And he started looking and he said, these are my dreams. You know, I'm dreaming this. And that's what started him realizing that alchemy was a Gnostic science that is revelatory.
Yeah, which brings us to the question, is C60 the philosopher stuff?
Well, I have actually come out publicly and said I thought it was.
Yeah, and if you think about it, now, I don't know, I'm the C60 guy, you guys
Yeah.
have probably heard it all.
Ken makes
especially-
purple power.
Yeah, well, it's now C60 power, and if
Yeah.
you go to
Oh.
shopc60.com and type in J10, I think all uppercase, there's a discount, J gets helped, you get a discount and all that good stuff. But in fact, that's how I got to C60 was the Moxy Fusion. Because I had read about, the late scientist this and the dead doctor that, and I didn't want to be, for my crew to end up that way.
Right.
So I went looking for radiation protection. I found this stuff called C60. One set of rats got C60, the other didn't. They hit them with a high fatal dose of radiation. The C60 rats lived. The control rats, of course, all died. So I got C60. We were taking it. We're all still alive. So I guess it worked for that. But I kept taking it, afterwards because I had more energy, better mental focus. And 7 months after I started taking C60, I went in to see my eye doctor, and my drusen or dry macular degeneration completely disappeared. Yeah. My electrical engineer on the job, Gary Rodriguez, he had severe wet macular degeneration because he had type 2 diabetes, right? And so he took C60 in MCT oil. I made it in MCT oil for him because medium chain triglycerides, which is a distillate of coconut oil, they are turned into ketones by your liver like that. So it's flex fuel for your cells. So if your cells can't run off glucose because you got type 2 diabetes, they could run off the ketones. So it's like flex fuel for your cells. And so it was a little over a year for him, and his severe wet macular degeneration went completely away, all healed up, and his type 2 diabetes went subclinical. And my case, like my optometrist was astonished. He had never seen drusen reverse itself in his many decades of practice. And obviously the other doctor, for Gary Rodriguez, freaked out because he'd never seen that happen for severe wet macular degeneration. And I
wish my dad had known about
and there's
that.
we have dozens of customers who've had similar experiences.
So what they did, just to reiterate the story, is I believe it was French, right? The French doctors.
Yeah, the French doctors.
They had a control group and a group that they gave the C60 to, and the control group lived a regular rat life, and the C60 group literally didn't die. Yeah, well, and they didn't get sick.
Well, they eventually did die. The last few, it was like 5.5 years. The last couple of rats had like
maybe like 120 or something.
Yeah, exactly. They had terrible accidents, so you could publish the paper. Because rats usually don't live 5.5 years, right? And so what happened? Well, first they had 3 sets. They had the control, and then they had 1 set that just got olive oil, and then they got the C60 group. And so the control group all died. When all the control group died, they actually stopped giving the rest of the rats C60 or olive oil, but they still kept living. Then the ones that had the olive oil, they died pretty quickly after that. And then the C60 rats, they just kept living. And even though they weren't getting C60 anymore, they were still living and living until the last 2 rats. In this case, it was a case of perish so you can publish.
Right.
But in the meantime, they had some smart researchers.
Literally perish.
Smart, and these were Worcester rats, by the way. Worcester rats are kind of like a wimpy rat, and they're actually designed to mimic rapid aging in humans. So Worcester rats kind of age like humans. And so instead of aging, they just lived like super long lifetime. So they didn't have they usually died of cancers and other degenerative diseases associated with aging in humans and Worcester rats, and they didn't. There was no cancers, no cognitive decline, none of that. They just lived to these really, really long, healthy rat ages.
Which is
until they went off.
Philosopher's Stone. The C60 is black. Philosopher's Stone is black.
Yeah, it's black.
Yeah. C60, there's a peculiar geometry about the Philosopher's Stone. That's what they say. The C60 looks just like a buckyball, has peculiar geometry. I mean, over and over, it gives long life, longevity, which is what it promises. And
there's a way that it could actually be harvested. Now, right today, this is how we make C60. It was actually discovered in 1985 by Richard Curl, Robert Spoley, and Harry Croteau. And they got a Nobel Prize in 1996, but it solved an outstanding mystery in astronomy. And giant red stars, they've gone from the hydrogen burning stage to the helium burning stage. They burn helium into carbon and they bubble off their surfaces. And like 0.1% of the carbon bubbling off their surfaces turns into C60. And that's the way we make it in the lab. We actually have an argon atmosphere. We have a chamber. We have 2 carbon rods in an argon atmosphere chamber, and you run electricity to it, and you turn the carbon into like a powder. And if you do it right, you can get about 10% of that carbon turns into C60. There's a little C70, a little C84, and then you have to separate it. And there's a whole process where, like in most cases, we use sublimation. That's when you take a solid goes into a gas, and then it condenses. And that way, all of our C60 is solvent produced, so it's never exposed to, all of our C60 is produced by sublimation. So we use sublimation. That's like a cousin of evaporation. The C60 and the ashes, which is 90 something
Keeps it
percent.
pure.
Yeah, so the C60 is turns into a gas, floats to the other side of the sublimator, condenses on the plates, and then it's taken off. And that's how you get 99.99% pure C60. Sublimated C60 is what we use. Most C60 is industrially produced. They use solvents, toluene, methylbenzene, and no one carcinogen.
Oh, wonderful.
And then they just dissolve, it'll dissolve in that, and then they run it through these diffusion columns, and then they flush them, and then they got the C60 dissolved in the toluene, and then they bake it off, but there's always a little bit left. And so that's why you always want to buy sublimated C60. Just like you know, and instead of solvent-based C60, and it needs your product. We're not the only one that uses sublimated C60, by the way. But the ones
I'll put a link.
yeah, the ones that care and do want to make a quality product use that. They don't use industrial C60 that's made by solvents. They use sublimated C60, which is specifically designed for human consumption.
And we don't really understand how it works, do we?
Well, it's a powerful antioxidant. What it does, there's 4 big antioxidants in our body that make the mitochondria run, but they also do lots of other things. One is CoQ10. You can supplement for that. And there's glutathione, there's some supplement, but there's superoxide dismutase and catalase that work together to take care of the most damaging oxidative radical in the body, superoxide. And by the way, C60 also works on hydroxyl ions, the second most damaging oxidative radical in the body, and usually the main thing produced by radiation. And so there is no way to supplement for SOD and catalase, but C60 does the job of both in one shot. And so when you take C60, it passes the gut barrier, passes the blood-brain barrier, goes into the cells by endocytosis, into the mitochondria by endocytosis, where the mitochondria use it to neutralize superoxide. And as we get older, our SOD levels and our catalase levels go down. So if you take C60, it allows your mitochondria, they're little organelles. They have their own DNA. They got their own control thing. Right. So if they don't have enough SOD and catalase, they just turn down the energy level, right? They turn down the thermostat. Take C60, they can turn the thermostat back on. Now your mitochondria are making ATP, the energy molecule for like 95% of all the things that happen in your cell. And then all the good things that come from that. But the thing is, C60 only reacts with superoxide and the hydroxyl ion, which the body does not use as signaling molecules. Now, there's things like hydrogen peroxide, nitrogen oxides, and a whole bunch of others based around sulfur, iron, and zinc. These are actually oxidative radicals, but the body uses as signaling molecules. And so, but C60 doesn't interact with them. That's why there is no antioxidant except for C60 to increase athletic performance. Because if you take a lot of vitamin C and vitamin E and vitamin D, you're taking huge amounts of that. At some point, they start interfering with those signaling molecules, and your thing goes off. Right. But because C60 doesn't interfere with any of the body's signaling molecules, it's safe. They use C60 at 5,000 to 10,000 times the health beneficial response, and there's still no toxicity because C60 doesn't interfere with the body's signaling molecules. So it only goes with superoxide and the hydroxide, and that's it. And so it's the only antioxidant which increases athletic performance, and it's completely safe.
Well, I can tell you this: I take it every day, and thanks to you. And I was thinking the other day that I'm actually physically working about twice as hard as I was 20 years ago.
Oh yeah, it not only does that. I used to be in in Colorado, right? And before C60, before electrostatic pulse, before that, I was actually during the electrostatic pulse age when I was doing that. That's another technology someday we'll talk about. But I was working in a grow thing. Because I had this pulsar, I could put like 80% more bud on your plant, or whatever. It's one of the other science discoveries, right? Which sits gathering dust. But and what I did is I also was using C60 because it was after Moxy stuff, right? And I would give the employees there when I was like running the place, and sometimes it was like on Saturdays, Friday nights when everybody else had to leave, so they gave me, and I would be running the place, and I would give all the employees C60, and I found I could get 35% more work out of them. So any business owners out there, if you want to get your employees to work better, just give them C60, especially executive branch. You will get they stop arguing, their minds become clear and focused, and they just go out and work hard. Man. So I got 35% more work out of them every time I use C60. It was amazing. And they were happy. They were happy, productive workers. I mean, anybody out there who has employees should be using C60 with your employees to make them happy and productive. They don't bitch. They don't argue. They just go out and do their job. and with a smile on their face. It's wonderful.
Because they have more energy.
They have more energy, and it makes them happy. All the endorphins and stuff start kicking in, and the dopamine comes back online because your inflammation goes down. It's just, but we've been digressing. We should get back to how C60 might be the Philosopher's Stone and how ancient people could have made C60.
That's right. Let's talk about that.
Let's talk about that. In C60 is made in nature. Sure, in the universe, 90, most of it comes from the cores of the atmospheres of giant red stars. But on Earth, it's made in lightning strikes. In fact, the burnt wick of your candle is like 0.25% C60.
Okay, now wait a minute. Lightning strikes are plasma. Candle flames are plasma.
And
Is plasma making this?
well, yes, it's plasma made, yeah, and the star atmospheres of stars, it's got to be made in a plasma.
Yeah.
Electrical spark, so it's something made in plasma. And and so also in biochar. In biochar, it's about 0.25%. Now, one thing about C60 is it's hydrophobic, that it likes to float. And so you could actually crush C60 into a very fine powder. And you crush if you had like a piles of burnt wicks of candles, or maybe really good biochar that burns in that carbon monoxide thing, you could crush it up really, really finely. If you had to crush it up super, super, super finely, you could put it in water. C60 is hydrophilic. I know hydrophobic, so it repels water. You can't. That's why C60 has to be dissolved in water, a non-polar substance, because C60 is non-polar, oil is non-polar, so you dissolve it in a non-polar substance. Water is polar, and C60 repels from that because it's perfectly spherical. Water is like a north to south pole, and so C60 floats. So you could technically.
Are you saying C60 is a monopole?
No, it's a non-pole. It has non-polar. It has no pole at all.
What?
It's just because it all goes around.
Oh,
it's like a daisy chain,
right,
but in 3 dimensions. So there's no
sort of like a what do you call it? The strip.
The Mobius strip, kind of like the same thing magnetically. So it doesn't interact. And so technically, if you did it really, really fine, the stuff that floated off would be a high concentration of C60. And
so you just float it off the top.
Yeah, whatever floated on the top, do it a couple times, then take it, put it in an oil, and sit on the thing and make incantations over it. And pal, you got the elixir of life. And so that was totally doable for thousands of years.
Sure.
Because anybody can make biochar. Anybody can make, burnt wicks and candles.
It could easily get accidentally discovered.
Yeah, or somebody taught them about this.
Right.
A cheap and easy way. Of course, today, if you want to do it right, it's done in this laboratory. Like all RC60 is exposed to is helium and argon. That's it. And
does charcoal have C60 in it?
Biochar does. Regular charcoal maybe has 0.05%. It's very, very low, but it's in there a little bit. Biochar, which is kind of like the burnt wick of a candle, it's about 0.25%. It doesn't get above that.
What about like burnt wood?
It'd be 0.01 or something. It's very low in a high oxygen environment, but when you limit the oxygen, you get a higher, but it's still like, it's something 0 point something at the very best, 0.25 at the very, very best.
Well, I mean, in the winter in Europe, you'd be burning a lot of candles.
Yeah, and so if you knew what you were doing, if somebody taught somebody somewhere and they extracted it, you could definitely make the Philosopher's Stone in the Middle Ages, in prehistory, easily. And it's black. It extends long life and great health. And there's a whole thing on how to do it.
Oh, I did a whole talk on it.
Which is ironic because not only do I do alchemy, but I sell you the Philosopher's Stone.
You did.
I commercialized it. Sorry, guys.
On the show.
I know that's a little what I say, what is it, heretical or something?
Heretical.
Yeah.
Yeah, no, that's why you're on the show, because you actually make it practical. That's what I appreciate about you, because all the other people that talk about alchemy, besides me, are always talking about it in abstract terms, and I know that it's not abstract.
Yeah, you don't need me. You just read the damn paper and do it yourself. The Scotia group, they left their plans, enough of them. You could do it their way. Their way is a pretty good way too.
Make gold, folks.
Gold. Well, actually, I would recommend, if you do the gold, you got to be careful, because what you're going to also make osmium in some cases, and osmium tetraoxide, osmium with 4 oxides, is actually rather toxic. So after you make your material, you need to wash it with sulfuric acid, and the osmium tetraoxide, if there's any there, will dissolve in the sulfuric acid. But the gold and the platinum group metals won't. And then you can wash that out, and then you can recover like the zirconium oxide with a pan, and then you have a little bit of metal left at the bottom. and then you put that in a bone china thing and you heat it with a blowtorch and you'll get like a little tiny BB of like platinum group metals. But make sure you vent it. Don't breathe the fumes.
$2,000
Yeah,
ounce
exactly.
right now. And that'll probably go down once this gets out.
Yeah.
And he's
Well, it is
intending
out.
on getting it out, so.
I'm telling you how it's done now.
Yeah.
How do I know it's done unless it's already being done? But we won't even talk about that.
So do it, make your gold and sell it while you can.
Oh, and platinum group metals.
Platinum.
Zirconium half oxide.
Yeah.
That's the safer one. It doesn't make much osmium. So it would be a safer one, but still you got to be careful. First, you're going to be making some radioactive noble gases. Don't Madam Curie yourself, or in this case, who's that other guy? Fleischmann. Don't Fleischmann yourself. Don't Fleischmann yourself. And because you're going to be making X-rays, you're going to be making radioactive noble gases. They're short term, right? So they don't live.
And do it outside.
Do it outside. Yeah, you don't want to. Yeah, just don't. I don't want to be responsible for people X-raying themselves, and
Yeah.
Because those scientists didn't know. No. Fortunately, I've actually talked to the organization, and so hopefully most of the cold fusion guys that are still using the platinum, the palladium cold fusion cells and venting into the laboratory air and breathing it, please don't Madam Curie yourself.
Yeah, you got to be careful.
Or Fleischmann yourself.
This may be why they're keeping it hidden. We don't know.
Well, they thought that the evil deep state was killing them all. They were killing themselves. Ken Soldiers, he died but that was probably, he didn't have any, he was making a lot of X-rays. Every time one of those solitons hit it, the Leclerc guys, they're probably dead from the radiation poisoning. And there's a whole bunch of other guys that died, except for a couple of Russian dudes. They were smart. They put everything, they were doing uranium and they were blasting it the same way, but they put everything inside a really super solid stainless steel container. So nothing leaked out of that, and they got away. And so the Russians are still alive. They were smart enough.
The Russians.
They knew something was going on. After they were done that they found that the heavier isotopes of uranium were depleted relative to the lighter ones, which would happen under Moxy Fusion. Because there was metal and oxygen in it, because they had like electrolytic stuff, and it was a big blast thing.
Well, there you go, folks. Alchemy is real. It's true, and you can do it yourself.
Yeah.
We can all do it, and we should do it. And we should flood the market with gold. And then that way, the bankers don't have anything to back up their money. And then they go away.
But you have the money. You have money.
And then we have the money and they don't.
Yeah, it's not who makes the gold. No, it's not who has the gold makes the rules. It's who makes the gold makes the rules.
And we can.
That's the new law of the land.
That's right. And this is what the age of Aquarius is going to look like. We're going to take control of our own interests and not have other people dictate to us what the hell is going on. All right, guys, I'm Jay Weidner. You've been watching Reality Check. You got something to say?
Oh, J10. Go to shopc60.com. Check out the products. We got a whole facial creams and skin lotions and everything. Jess, our CEO, was kind of behind the whole design of that. So they're like the top of the quality. We have the best manufacturer in the United States making them. They're all organic and all those other good things. So yeah, it's something you want. J10 at shopc60.com.
You'll get a discount and you'll get C60, and I'll get a little bit of money. Not that I really need it that much, but I appreciate it. And the face cream won't do me any good, but it might do you guys some good. So I definitely would get that. And do take the C60.
And one more thing. Any of you guys out there that do the Moxy Fusion and make the gold or the platinum group metals, send us.
Yes.
Send us a little bead. After you get done in the China bowl with the blast thing, send us a little bead and we'll show it on.
We'll show it and we'll talk about it.
Here we go. Here it is.
In fact, do take video of it too. Let's make this thing like just public all the way. Right? Okay, everybody. Thanks for watching. I'm Jay Weidner, and this has been Reality Check.